We're about to unravel the story of something we all totally take for granted. The fabric that literally makes up our world. It seems so simple, right? But its history is this grand epic of human innovation, and we're going to see just how deep that thread really goes.
No, I mean, really think about it. That simple piece of cloth you're wearing right now, it connects you to a story that's tens of thousands of years old.
See, this story is so much bigger than just threat. It's about how we, as humans, solved a simple problem over and over and over again. And in the process, we accidentally powered an industrial revolution and, get this, even helped invent the modern computer.
I mean, just look at the difference here. On the left, you've got a vertical loom from nearly 4,000 years ago. And on the right, a sleek, high-speed industrial loom from today. The journey from that thing on the left to the one on the right is just absolutely incredible.
All right, so let's dive in. We have to go all the way back to the very beginning, where the fundamental problem wasn't about speed or power. It was simply, how in the world do I organize this handful of threads?
You gotta understand, for millennia, progress was painfully slow. I mean, we're talking about weaving with just your fingers. Then came the backstrap loom, where you literally used your own body weight to keep the threads tight. Every single step forward, like adding some weights to the bottom of the threads or building a simple frame, was a tiny but crucial improvement.
Okay, so then we get the vertical loom. And this was a huge step forward. For the first time, you have a real frame and this clever little tool called a heddle rod, which is basically a stick that helps you lift up the right threads at the right time. It was one of the first attempts to really systematize the whole process. And what's so cool is that this basic design is still used by artisans like Navajo weavers today.
Now this was a game changer. The pit loom. The big idea? Let your feet do some of the work. By sitting in a pit and using pedals to separate the threads, the weaver's hands were suddenly free to do just one thing: pass that shuttle back and forth as fast as possible. And that focus, freeing up the hands, that set the stage for a massive leap in speed.
So this whole idea of freeing the weaver's hands, that becomes the main obsession for the next couple thousand years. The big bottleneck was always the person doing the weaving, so all the innovation was about getting around our own physical limits.
And that leads us to the horizontal treadle loom around 1000 CE. This is probably the one you picture when you think of an old-school hand loom, right? Its genius was perfecting that separation of labor. Your feet play the treadles like organ pedals to create the pattern, while your hands are just free to fly, focusing purely on speed.
And then, in 1733, this guy John Kay comes along and invents the flying shuttle. And, wow, it's a simple mechanism, really. You just pull a cord, and it shoots the shuttle across the loom all by itself. But it literally doubled a weaver's speed overnight. Get this, it worked so well that it created a massive yarn shortage. Weavers were using thread faster than spinners could make it, and that pressure, well, that helped kick off the entire Industrial Revolution. Crazy, right?
So now you've got skyrocketing demand for cloth. What happens when human muscle just can't keep up anymore? Well, you bring in the machines.
And so, the power loom is born. It took all the same ideas from the hand loom, but instead of a person getting tired, it ran on the relentless power of a river and, later on, steam. This is the exact moment weaving moves out of the cottage and into the factory. It was a total transformation of society. But to really get just how big a deal these power looms were, we kind of need to peek under the hood. What is weaving, actually? Well, it turns out it's just 3 basic moves, repeated over and over and over, whether you're doing it by hand or with a 20-ton machine. It's this simple repeating dance. First, shedding. You make an opening, a little tunnel, by lifting some threads and lowering others. Second, picking. You pick your cross thread and send it shooting through that tunnel. And third, beating up. Use a big comb to basically slam that new thread into place to make the fabric tight. Shed, pick, beat. That's the whole show.
So here's the irony. By the 20th century, that amazing flying shuttle, the invention that changed everything, it was now the problem. It was the bottleneck. Think about the noise of thousands of these things clattering back and forth. They were slow, they were loud, and they were dangerous. The next big challenge? Just get rid of the shuttle completely.
But hold on. Before we get to the super fast modern looms, we have to take this quick, fascinating detour back to 1801. See, there was this other problem people were trying to solve. Not speed, but complexity. And the solution they came up with, well, it changed the world in a way nobody saw coming.
Meet the Jacquard loom. You can think of it as the world's first programmable machine.
The program was a long chain of cards with holes punched in them. Each card controlled one row of the pattern. A hole meant lift this thread. No hole meant leave it down. It's a simple binary system, yes or no. And with this, you could automatically weave these mind-bogglingly intricate patterns that were pretty much impossible to do by hand.
And this is the mind-blowing part. That simple idea, hole or no hole, 1 or 0, is the fundamental concept behind all modern computing. This Loom's punch card system directly inspired early computer pioneers. So yeah, you could say the first complex computer program wasn't for calculating numbers, it was for weaving fancy tablecloths. Okay, so back to our mission, getting rid of that clunky old shuttle. Modern looms did it with some seriously brilliant ideas. Instead of throwing a heavy block of wood, some use these long, flexible metal fingers called rapiers. Others use a tiny metal bullet to shoot the thread across. And the fastest ones? They use a literal jet of compressed air or even water to blast the thread into place. They are unbelievably fast and so much quieter.
And that brings us to the final piece of the puzzle, the digital revolution. This is what took these amazing mechanical wonders and gave them their incredible precision, turning them from clever machines into full-blown robots. If you could see an old factory floor, it was just chaos, one giant engine powering everything through this crazy, dangerous forest of belts and shafts. Now it's so much cleaner and more elegant. Every single loom has its own dedicated electric motor. Simple, efficient, and a whole lot safer.
But the real magic isn't just having a motor, it's the control. Modern looms use a direct drive servo motor. Forget clutches and brakes, the motor is the clutch and the brake. It can start, stop, and change speed with the precision of a surgical robot. It's just incredible accuracy.
Which brings us to today, where the thread is fully digital. Those old jacquard punch cards? They're now just computer files. You can email a new fabric design to a factory on the other side of the planet, and they can start making it in minutes. And we're not just talking about t-shirts anymore. These looms are weaving with carbon fiber and Kevlar. They're even doing 3D weaving, creating complex parts for airplanes and race cars that are stronger and lighter than anything made before. It's pure science fiction.
So just think about that journey, from a few threads twisted by human fingers all the way to a 3D woven part for a jet. The story of the loom is really the story of human ingenuity itself. It makes you look around, doesn't it, and wonder what other simple thing in this room has a secret history that's just as amazing.